ChatGPT is brilliant, but sometimes we give it more credit than it deserves. We can make big mistakes if we don't fact-check an AI's output. As a rule of thumb, try to remember the following principle. An expert in their field works with AI and reasons within the AI conversation box rather than copying and pasting every answer and mindlessly trusting. In fact, OpenAI clearly states at the bottom of the screen, ChatGPT can make mistakes. Check important info. You can obtain two types of undesired behavior from Gen AI tools: hallucinations and inconsistencies. Hallucinations are observed when the AI provides false output to generate any production. Now that you understand how Gen AI operates, you realize that models often predict the next word in a sequence using context to enhance accuracy. Despite the power and sophistication of these models, their predictions can occasionally be incorrect. Another reason hallucinations could occur is that the AI could be trained on factually incorrect data to begin with. If trained with false data, the model will likely produce incorrect outputs, right? A legitimate tactic for dealing with hallucinations is to give an instruction that says, "Provide an answer only if you know the answer." In some cases, this type of prompt engineering could be helpful. On the other hand, inconsistency occurs when a model provides very different responses to the same question. Especially when ChatGPT first came out, it felt like the AI was smarter in specific sessions and dumber in others. This is due to variations in the hardware used to run the model, or other uncontrollable factors, primarily when the model is hosted externally. One unproven way to reduce inconsistency is by instructing the AI to take its time. Hopefully, if you do that, it won't rush to produce a response, and the system could allocate more hardware resources for every prompt. In any case, detecting hallucinations and inconsistencies and finding ways to deal with them will be one of the major topics of AI research in the years to come, and will surely become a market worth billions. The two main factors determining how powerful an AI model is are dataset and model size. A larger, higher quality dataset significantly enhances the model's learning potential. Meanwhile, the model's size determines its learning capacity. Think of the large dataset as a library full of books. All else being equal, the more high-quality books we have in the library, the more we can learn. In this analogy, model size can be compared to a student's learning capacity. Students who can remember and internalize more information can use this extensive library. Similarly, a larger AI model that has more parameters will be able to capture more intricate patterns and make more complex decisions based on the information learned from the dataset. So, in general, the larger an AI's dataset and model size, the higher its performance can be expected. But building the largest model isn't always the best strategy, because it involves a clear trade-off between performance and cost efficiency. It's expensive to acquire large, high-quality datasets, and even more costly to set up and purchase the computing power to train a considerably large model. So, budgeting is a crucial topic and a fundamental skill AI developers need to acquire. You can't start building your AI model and then figure out how big it will be and how much it will cost during the training process. Instead, it's much better to consider the available budget beforehand and decide what portion will be allocated to data acquisition and computing power. This aspect is quite tricky. Sam Altman revealed in an interview that training GPT-4 cost OpenAI over $100 million. Most organizations cannot afford multiple attempts at training their AI models and must succeed on their first try. Finding the right balance between how well an AI works and how much it costs is key to AI development. Bigger AI models need more computing power during training and operation, which can get expensive. Creating a large model should hinge on a significant boost in effectiveness that aligns with the organization's goals and resources. In some cases, building smaller models that can be retrained and fine-tuned frequently makes more sense. Training smaller, specialized models is more cost-effective and faster than using vast resources to train a large model for limited applications. One key issue when building customer-facing applications is that today's users have low tolerance for slow loading times. The latency issue becomes even more critical when business customers want to use Gen AI to boost personal productivity or build products based on an AI model. In such scenarios, the stakes are higher because delays frustrate users and directly impact business operations and revenue. Regarding latency, the biggest challenge of LLMs today is that the models use an autoregressive architecture, where each word generated depends on the words that came before it. This sequential nature limits the speed at which outputs can be produced, because each step must wait for the previous one to be completed. If an LLM sequentially generates each word in the sentence, "My favorite sport is basketball," at 0.2 seconds per word, it would take 1 second to complete the sentence. To solve this issue, AI developers are exploring different architecture types and parallel computing. An effective immediate strategy is to optimize model size. Smaller models are often faster than their larger, more complex counterparts. When we see diagrams like this one, it's natural to expect that the next version of an LLM will be significantly larger than the previous one. But one major issue is likely to hinder this process. If GPT-4 has already read and processed a significant part of the publicly available data on the internet, where would the new data for GPT-5 come from? AI developers risk running out of data and face a potential slowdown in the growth of model capabilities. Moreover, now that ChatGPT has gained popularity, there's a significant risk that many of the new articles and materials posted online will be written using AI. This makes learning new or nuanced information challenging for future LLMs because they frequently encounter repetitive or derivative content. Future models will simply echo what previous models have written, thereby increasing the risks of hallucination, biases, and inaccuracy. Another obstacle to data availability is that following the hype surrounding Gen AI, several large organizations worldwide filed lawsuits and prohibited data scraping of their websites. Some of the first litigations came from the New York Times, Shutterstock, and best-selling author John Grisham, while platforms like Reddit and Quora changed their policies to make it illegal for AI developers like OpenAI to scrape their platform data. To mitigate this issue, OpenAI has started a content licensing program and has already signed agreements with several organizations that own some of the largest proprietary datasets in the world. OpenAI offered publishers between $1 and $5 million a year to access archives and train its Gen AI models. They signed deals with organizations like Shutterstock, Axel Springer, the Associated Press, Le Monde, and Prisa Media. In the future, competition between big tech firms developing LLMs will likely significantly increase the price of large proprietary datasets.